Hello students, welcome to Target IES. In this video we are going to start the very first module related to structural analysis. So this is a new subject which I am taking. So this is a very high weighted subject for ESE exam because in ESE 10 to 15 questions come every year, so you will be getting 20 to 30 marks. 20 to 30 marks. And in GATE this is not a predictable subject. Okay, the highest number of marks ever asked in GATE for structural analysis is 20 marks, and there are years where there was not even a single question from structural analysis. 2011 or 2012 le lo, 2 years there were not even a single question from structural analysis. But if you take the average marks, it will be around 6 to 8 marks. So 20 was your highest and average marks 6 to 8. But the very good advantage of this subject is it has only 6 chapters, and if you are listening to my videos, at the end of this all 6 chapters you will be perfect in all the ESE and GATE questions, and you will be scoring out of this marks. Okay, there is a no chance that you will be skipping any question. There is a no chance that you will be making any mistake. Okay, so if you are completing this package, 100% chances are there you will be scoring out of 30 out of 30 marks, and here 6 or 8 out of 8 marks. Fine. So there are basic questions which people generally ask me. Is this course enough for ESE and GATE? Ha bhai, this course is enough for both ESE, GATE, and it is also enough for all state PSC exams or even railway JE, SSC JE, whatever you are preparing. This course is more than enough. And very important question, will all questions come from notes? Yes, bhai. I can assure you all questions will come from notes itself. All concepts related to that question. Question will not repeat obviously because they are made by IIT professors if you are taking it. The question as it is would not repeat, but the concepts which are involved in question will be repeating, and 100% if you are taking structural analysis, right, the concepts are already fixed, so 100% chances are there that all the questions will be from the notes itself. Why I am so confident, I will show you. So basically I have made these notes, just a second. So this is not my own notes. I have made these notes collecting the notes of all 3 premier coaching institutes in India. Okay, नाम तो नहीं ले सकता, but तीनों institutes के notes मैंने collect किया है, आपको बता दूंगा. So this is the notes number 1 of a coaching center which is based in Hyderabad, and this is the notes number 2 which is based on a coaching center based in Delhi, and I also have one more notes, वो भी बता दूंगा. Yeah, you can see this is one more notes related to one other important coaching center in India. So what I have done is I have clumped all this coaching center material into one beautiful material. Okay, so you can have a look. This is the material which I am providing. Every chapter is clearly written. So तीनों book मैंने clump कर दिया है. There is no concept which is being missed. So if a coaching center A misses a concept, obviously it would be covered by coaching center B and C, right? So that every concept of structural analysis will be thoroughly completed. And at the end of each and every chapter, as usual, जैसे हमने फ्लूइड मैकेनिक्स को किया था ना, वैसे ही हम करेंगे प्रीवियस ESC and GATE questions also. So all the important GATE questions and ESC questions we will be solving. At the same time we will be solving lot of questions within the chapter itself. So I am solving more than 400 to 500 questions. कितने? I am solving more than 400 questions at least in structural analysis. After doing these many questions na, there is a no chance you will be skipping any question, whether it is of GATE, whether it is of ESC or any state PSC exam. Okay, so at the end of this course you can expect you will be scoring out of out marks in all the examinations related to structural analysis. So this structural analysis classes basically take 40 to 50 hours of time. Okay, but here everything I have clearly written already, so I need not write from the scratch in front of you, and I need not give you time to copy this because you will be having the same hard copy as it is. जो मेरे पास book मैंने बनाया है ना, यही copy आपको मिल जाएगा hard copy में. So you need not also waste your time in copying down whatever I have written, so that we will be saving almost 75% of the time, and my target is to finish the entire structural analysis within or around 15 hours. Okay, so I value your time, and I am trying to finish all these 400 questions including all the concepts of all these 6 chapters within 15 hours. That's my target. It might take little lengthy also, maybe around 16 hours, but we'll be finishing in this time itself. So now let us start from the very first chapter, which is determinacy and indeterminacy. So काफ़ी simple chapter है, the very first and basic chapter of structural analysis. In colleges basically you will be given some beams like this. So बोलो क्या beam है? This is a fixed beam because both ends are fixed. So how many reactions will be there? Here it's a fixed end 3, here it is a fixed end 3. So total number of reactions 6. How many equilibrium equations I have? 3. Sigma H is equals to 0, sigma V is equals to 0, sigma M is equals to 0. So 3 equations I have. So what is my static indeterminacy? R minus S, which is 6 minus 3 is equals to 3. ये पढ़ाया जाता है कॉलेज में, बट क्वेश्चंस ऐसे नहीं आएंगे ESC और गेट में. सो आई विल शो यू अ रफ आइडिया हाउ द क्वेश्चंस इन ESC एंड गेट लुक लाइक. सो दिस इज अ गेट क्वेश्चन. वो भी पुराना वाला है 1992. आजकल तो और हार्ड क्वेश्चंस पूछ रहे हैं. आई विल शो यू नो इश्यूज. सो यू विल बी गिवन अ स्ट्रक्चर लाइक दिस, विच इज अ फ्रेम. सो आई हैव अ फिक्स्ड एंड हियर, आई हैव अ pin joint here, I have a roller support here, and I also have a roller support and an internal hinge somewhere here. So and he is asking to find the static indeterminacy and kinetic indeterminacy. Same question here also. Here we have a horizontal shear release, and here we have a hinge, here we have pin joint supports, and he is asking to find what is our static indeterminacy and kinetic indeterminacy. Question कुछ इस तरह से आएंगे. Don't worry, at the beginning आपको लगेगा कि कुछ बड़ा है, but I can assure you at the end of this modules related to the very first chapter you can solve this question within 30 seconds. कितना? Within 30 seconds. चाहे कितना भी बड़ा question हो, you will be solving within 1 minute itself. Okay, so let us start the very first module with our introduction to structural analysis. Okay, so what is this analysis term first of all? So in the analysis term, if you are given some external load to a structure, okay, so here I have a cantilever beam. एक side fixed है, other side open है ना. इस type of beams we call it as cantilever beams. Okay, so I have given some external load. When I am giving a external load like this, what will the structure do? It will develop some internal reactions. What are the internal reactions which it develop? It develop axial force, यानी force in this direction. Okay, and then it develops shear force. The load is like this, right? So I'll be getting my shear force in vertical direction, and it will be also developing a bending moment at this ends. Okay, so these 3 internal reactions we have to find out the values. That is called as analysis. Okay, we are analyzing what are the values of these internal forces of a structure. See, you can't just draw a diagram like this and call it a structure. ये गलत होगा, because to be classified it as a structure, first of all it should be a stable system. क्या? It should be a stable system. What is this stable system? If you are applying a load, what will happen? It will obviously deflect, right? ये जो curve पहले था इस तरह से, a straight line. When I am applying the external load, it will obviously deflect, so it will get a new shape, something like this. Okay, now when I am removing this load, what will happen? If I remove this load, this will go back to the position 1. So this type of systems we call it as stable system, and only this type of structures I can classify it as structure. ठीक है? So here you can see the deflection curve. It is not straight, it is non-linear. It is not a linear curve. Linear यानी something like this. So initially it was like this, and it has deflected when applied load into like this, a straight wala. So if it goes like this, now you can't call it as structure. It should be non-linear only. Why? Suppose ये आपका बीम है जो आपके रूफ में यूज़ किया गया, and you are sitting below it. Okay, so if there is some load applied, so what will happen? It will deflect very less because there are some internal reactions being developed, and this is stopping the beam to fall on your head. Fine. So same thing, instead of having a fixed support, if I have a pin support, मैंने क्या कर दिया है? Instead of having a fixed support, I am applying a pin support, यानी hinge मार दिया है मैंने यहाँ पे. So I will tell you what is the difference between fixed support and hinge support here itself. For example, this is my column and this is my beam. So what I will do is, in fixed support, I will attach my beam to the column or whatever it is, and I will apply many bolts, 4-5 bolts, or I can even weld it. So what I can do, I can weld it around its sides. Or I can apply multiple bolts. So what will happen? It will not deflect easily. But if in the case of hinge, what happens is, you are attaching your beam with the help of only one rivet or with the help of only one bolt. आपका ड्राफ्टर रहता है ना, इंजीनियरिंग ड्राफ्टर, it is easily movable like this, right? Because it is also a hinge support only. So if you see clearly, there will be a bolt passing through the beam and passing through your support. Okay, so this type of thing we call it as hinge support. So what is happening? There is only one bolt or one rivet through which it is attached. So what will happen if you are applying some load? It is free to move. इस तरह से फ्री से हिलेगा. Okay, so that is the main difference between fixed support and a hinge support. I hope I am clear, right? So now I have a hinge support. What will happen if I apply load? यहाँ पे आप बैठे हुए थे. Okay, so this is your, for example, this is your roof beam. It has been pin jointed and there is some external load added. So what will happen? It will fall directly on your head. Okay, so this type of structure, which is unstable structure, and if you remove this load, will it come back to its original position? No, because there is no moment of resistance developed, right? If it was a fixed support. So what used to happen? Whenever there is a deflection, there used to be some moment of resistance. This moment of resistance used to take this beam back to its original phase. But here there is no moment of resistance because it is a hinge support. If you are moving it like this, it will stay like this only. It is not going back to its original position. Whereas in fixed, it was completely welded, right? Even it tried to bend like this, non-linear. If you remove the load, it used to go back to its original position. Simple है ना? So what is happening? It will fall directly on your head और लोग आपको मारेंगे if you call this as structure. So this is the difference between mechanism and structure. And in structural analysis, we will be dealing with only the structures which is a stable system. Okay, so everything is clearly written. एक बार पढ़ लीजिएगा, so it will be clear. I will read out for you once. It is a stable system which can undergo a deformation on application of external load. If the deflected curve goes back to its original position on removal of external load due to internal resistance is called a structure. Okay, so the same definition which I have just explained. If you are applying some load, it will deflect. If you are removing this load, what will happen? It will go back to its original position. Okay, this type of things we call it as structure. Fine. So here, have you seen the moment of resistance? What is the direction of this moment of resistance in case of fixed beam? Okay, many people make mistake in calculating the direction. थोड़े यहाँ पे clockwise लेते हैं, थोड़े anti-clockwise लेते हैं. Okay, basically there is a very simple logic behind this. If you understand the logic, you will never make a mistake. तो ये पहले बोलो, this is not your applied moment. This is moment of resistance. This is the internal reaction. Okay, so what is your applied moment? Your applied moment is force into distance. If you have some beam like this and you have applied some load here, you used to get, for example, F, and this distance is X. So what will be your moment at this point? At this point, your moment will be F into X, right? So that was your applied moment. It will be, if this is like this, na, so your moment will be something like this at this point. So we call it as clockwise moment, right? ये तो जानते हो ना, clock कैसे रहता है? 12, 3, 6, 9. If you are going like this in the direction of clock, we'll be calling it as clockwise moment. If you are traveling in reverse direction of clock, आप जा रहे हो like 3 to 12, from 12 to 9 in this direction, we'll be calling it as anti-clockwise moment. So if your force is something like this, you can easily say इस तरह से bend हो रहा है. So what you are getting a clockwise rotation. So it is called as clockwise bending moment. So what is happening to moment of resistance? काफ़ी simple concept है. Your applied moment and your deflection will be in same direction. See what is happening? The load is like this, so it will try to move in this direction, which is clockwise direction, right? So your deflection is also in clockwise direction. Common sense hai. But your moment of resistance, if your slope is in this direction, if your deflection, slope यानी deflection दो भी एक ही है ना, so if your deflection is in this direction, to nullify it, it should be, your moment of resistance should be in opposite direction. If it is clockwise, your moment of resistance will be anti-clockwise. Okay, if your deflection, suppose your load was something like this, you have applied load at the bottom, so it will try to deflect in this direction. So this was your deflection theta, right? So this is anti-clockwise direction, see it is moving like this, right? So to nullify this, what will happen, you will have a moment of resistance which is traveling in a clockwise direction. So we'll have a clockwise moment of resistance so that it can go back to its original position. Simple. So I have already made the note of this, so you can just read it. Applied moment and slope will be in same direction. Moment of resistance and slope will be in opposite direction. Now coming to the mechanism definition, I hope it is very clear for you what is mechanism, right? So it is an unstable system which will not recover from the deformation on the removal of external load, that is no internal resistance. It is called as mechanism or unstable structure. I hope it is clear, right? No issues. The only point which you have to remember is in mechanism your deflection curve is perfectly linear, straight rahega, whereas in your structure it won't be linear, it will be deflecting as a non-linear curve. Okay, so I have given a note, deflection curve varies linearly in mechanism. If the deflection curve varies linearly, then theta is known as rigid body rotation. So what I have just said, if your rotation is linear, so if you are rotating something like this, okay, then I will be calling it as rigid body rotation. Yaad rakhna, it is called as rigid body rotation. Why? Your entire body has been rotated to a new position. Okay, there is no change in the cross section of this body, right? So it is called as rigid body rotation. Fine. So let us see one more example of this mechanism and a structure. Okay, so here I have a simply supported beam. Simply supported beam meaning both your supports will be pinned ends, okay, or hinge ends. So what is happening is when you are applying some load, so it is something like this. It is we have a pin support here, we have a pin support here, and the load is applied at the center. So what will happen when the load is applied at the center? It will deflect. So is the deflection curve linear? No, right? It is non-linear. So this is a stable structure and I can call it as a structure. Fine. Now let us see. I have added a hinge here. When I am adding a hinge, that means there are two members which are joined by a hinge. Okay. At the ends, again they are simply supported. Now what you have to do? You have to apply load at the center, right? If I am applying load at center, just see how it will deflect. It will deflect as a straight line itself. Common sense hai yaar. Structure analysis is nothing. If you have a basic knowledge, you can imagine how the structure will deflect. So it is a very simple subject. Okay, at the end of this course you will be completely perfect in structure analysis. Leave it to me. Okay, you can see it is linearly deflecting, right? It is a straight line. Here also it is a straight line. So same thing is happening. So what will happen? See, the sar pe girega. Log marenge, right? So this is a unstable structure. So I hope it is clear. Why it is unstable? Because you have a rigid body rotation. Your entire body is rotating without changing its cross section. Okay, so it is called as rigid body rotation. There is one more thing which is called as rigid body translation. So rotation was rotating, right? In translation, it is entire your body is moving without showing any resistance. For example, we have a roller supports. Okay, so if I have applying the load, what will happen? Roller supports will not give any resistance in horizontal direction. So when I have applied load in horizontal direction, it will move to new position to right? This beam जो पहले यहाँ पे था, now it has moved to this position. So it is moving, right? So you can't call it as structure again. This is a mechanism. Fine. So what will happen? Just imagine. So you are a civil engineer and you are constructing a home, and you have constructed an apartment like this. यहाँ पे जो बीम था, इट इज़ अ विंडवर्ड बीम. ये अपार्टमेंट है. दिस इज यहाँ पे जो वॉल बनाया आपने, सो इट इज़ ऑन अ बीम विच इज़ एक्सपोज टू विंड. सो इफ यू आर गिवन अ रोलर सपोर्ट हियर, okay, if there is a high wind, what will happen? Your wall will move into your home. So will you call it as a structure? Anyone will buy this? No, right? You can't classify it as a structure. It is unsafe for the people living inside. Okay, so this type of things, it is a mechanism. Okay, whether it is a rigid body rotation or a rigid body translation, it will be a mechanism and you can't call it as a structure. Structure yani only stable structure. Fine. So now coming to the classification of a structure. This is not a classification of structure but a classification of diagrams. Okay, for example, if you are drawing a beam, what will you do? you will just draw something like this AV. बोलोगे सर ये मेरा beam है. Okay. So virginal beam will be in 3 dimension. It will have length, it will have breadth, and it will also have the thickness, right, or height. But here you are giving beam only 1 dimension. length दे रहे हो, breadth और thickness तुमने तो neglect कर दिया है, right? So this is how you represent beam, right? So this type of structure in which you represent your structure only by 1 dimension and you neglect other 2 dimension, we call it as skeleton structure. And this is the skeleton structure we use in structural analysis mostly. Okay, so if you are drawing a frame, what you will do, you will draw column, you will draw beams, and then you will draw a column. Okay, so you are not drawing your dimensions in the other angle, right? You are not drawing the breadth, you are not drawing the thickness. Same happens with the trusses also. You just join your straight links, that's it. So this is about skeleton structure. And some structures you can't just define them with 1 dimension, you need 2 dimension. For example, slab ho gaya, you can't just draw a line and say this is a slab, right? You should clearly draw at least 2 dimensions to be classified it as a slab. Okay, so the structures which need 2 dimensions, we call it as surface structures. Okay, 2 dimensions are predominant, for example slabs and plates. So there are some structures in which all 3 dimensions are important. For example, foundation. If you remember your RCC subject or steel structures, what you used to do, you used to give your drawing in both dimensions, right? So you used to draw something like this. ये हो गया आपका top view, ये हो गया आपका bottom view. So you used to get something like this, right? So that is about solid structure. Here all 3 dimensions should be specified in the drawing itself. Okay, so I hope it is clear. In structural analysis we will be using skeleton structure only, so only 1 dimension is more than enough. So need not waste your time by drawing a beam like this. Okay, don't waste your time, you just have to draw. If a fixed beam is given, you just have to draw something like this. If a simply supported beam is given, you just have to draw something like this. I hope it is clear. So in the next module, we will study in detail the classification of structures, and we will also start doing lot of problems related to determinacy and indeterminacy. Fine. So have a good day. See you in the next module.